Now, today our lab is on. Is lab number 10, and we have lab number 10. In lab number 10, we have part 1. In part 1, we have discussed the water tank level alarm system using LabVIEW. The design of the level ranges from 20 to 100 liter. You have to uh, draw a new get a new VI. You have to get new VI, and first step is to draw a module of slider horizontal, slider vertical with a module of tank. Okay, so we have to add these module from here. Add horizontal module and a vertical slider, and then we have to add a tank. This is the tank, so we have to edit it. This is flow in liter per second, and this is sorry this is flow in liter per second, and this one is the flow out in liter per second, and this one is the tank. So we have to now using press Ctrl plus E button, so we have to move toward the block diagram. So we have to press E. Now it is in a block diagram. So we are using these two input for the difference between two input, inflow and drain out. We are using subtraction. We are using as a input, and this one input as a subtraction input. Now these two input are accumulated by using adder. You have to add it. We are using adder, and this adder will be feedback to as an input. This is the feedback. Now we are using for upper and lower range, we are using in range and course. So we have to use, when we click on it and press a question mark, so then again click on it, you will get the pin configuration. This will be for first is for upper, this one is a lower limit, and this one is used for as a x3, and these two are used as a, one is Gaussian and second one is for range. So we are using this. Now we are connecting this input here, and we are connecting this upper and lower range with a constant. So upper range is 100 and the lower range is 0. So we have to design it first 0 to 100. Okay, sorry, click on it, constant, sorry, we have again click on it and use constant 0. Okay, now this is connecting to the output. The tank input is connected to the output of this ring. Now we have to use structural while loop. So for this purpose we have to again using structure while loop, and we are using this. Okay, now to stop this we are using a sorry, we are using a control. It will stop it. Okay, now we have to move toward the front panel. So now it is working. So after running, okay, this is inflow, this is outflow, so it is working. So for this reason we have to stop for digital display. Click on it, digital display. Now again run it. So it will give you a value 100. There is a delay in the display of value, so we have to use a timer. For delay we are using a wait timer. This value is in milliseconds, so we are using 1000. So 1000 is denoted as a 1 second. 1000 millisecond equal to 1 second. Now we have to move toward the front panel and again run it. So now it is inflow, and inflow is 10, and this is outflow is this is the outflow, so its value is changing. So we have to okay, now it is working, but but in a not very accurate way. We have to zero it. Okay, this is 95, 96. This is the inflow and this is the drainage, so it will give you value. Okay, now we have to stop it. We are going to add some parameter to control it, the continuously changing value. So we are using 2 two parameter greater or equal and less than or equal, greater than equal and less than and equal. So we connect this with this input is connected to this input, and we have to connect also this one. So we have to use one input as a 80 range, and this one is used as a 20 range. Now we have to add LEDs. A square LED. Now we are using another LED. Okay, so we are going to connect these LED, one for the upper range and one for the lower range. Okay, we have to click on it and we have to move initialize on output loop. So we have to use a constant value 0. So so it will start from 0. Okay, after this value. Okay, now we have completed. So we have to run it. So the upper LED will Boolean 1 is on because it is less than, the value is less than 20. If value is greater than 20, then it is again okay. Before greater than 80, it will alarm. Okay, so this is our lab. So we have to write down the steps which we have to follow. Subtract the inflow and outflow in step number 5. You have to accumulate it, and then step 6 we have to use upper and lower limit, and use a comparator for Boolean output as a LED, and to use the move initialize one loop out. Move initialize one loop out for the feedback on apply the move initialization one loop out for the feedback on output of accumulator in step number 10 we are using apply while loop and control to stop the system and extract data as a delay of 1 second, so use wait timer. So these are the steps you have to if you want to do it stepwise, or you have to do according to my video. It's up to you. So this is the lab 1 part 1. Okay.